Chapter 1, The Sciences of Anatomy and Physiology, Part 3. Sorry we had to go into a Part 3, but that was necessary. All right, so we had talked about negative feedback, returning the body back to its ideal levels, its set point. There are a few cases in the body where there's positive feedback. Positive feedback means moving the conditions in the body in the same direction as the stimulus, so moving it further and further away from the set point. This obviously isn't ideal for most hemostatic conditions, so it is relatively rare in our body, but it can occur, and then usually the endpoint is some big event, something very significant that then stops the positive feedback. So examples include blood clotting. So as blood clots form, they'll continue to grow bigger and bigger, and the big thing that leads to them stopping is when the loss of blood stops. So if you go to YouTube, you can find videos where people remove these huge blood clots from their nasal cavity. Pretty gross. Another example is labor, the whole childbirth process. The contractions start off more mild and spaced out, and then over time they become more powerful and closer together time-wise until eventually the climatic event occurs, the birthing of the infant. And then the third example is breastfeeding. Breastfeeding being stimulated by the suckling of the infant, and obviously when the infant stops suckling, that signals to end the release of milk. So the stimulus, the infant suckling on the breast, there are sensory receptors in the skin that are able to detect this stimulus and send information to the hypothalamus. Hypothalamus within the brain will then send signals to the pituitary gland to release a hormone called oxytocin. And that hormone stimulates the release of milk. So oxytocin releases the ejection of milk and then is released. Infant receives the nourishment it needs, and then when the infant is full, process ends. And since there's no more suckling, there is no more release and sending of oxytocin to affect the breast tissue. This is an example of a positive feedback loop. All right, finally, we have the very important overview of some of the various medical imaging procedures that we are able to utilize in our modern times. There are a variety of imaging techniques that involve the use of X-rays. X-rays can peer through the body quite nicely. However, X-rays are dangerous to the body. Overexposure can lead to lots of issues. So radiography. Radiography refers to the traditional form of X-ray where basically the X-rays are shot through the person's body and then they expose onto a film. So you get a three-dimensional structure put on a two-dimensional slice of film. And when X-rays are used, the denser the structure, like bones are extremely dense. These structures block the X-ray, so they are light in color. And then areas that are less dense, say the nasal cavity, the X-rays can pass through easily and expose the film. So it's part of the skull, the mandible, looks like they have some fillings there. Computed tomography or CT scan. Computed tomography is very amazing. Basically, the person's put into this very large machine. X-rays are shot toward them in lots of different directions, giving the computer information about the internal structures in 3D, in 3 different dimensions. And then on the computer, you can look at the body by sections, as we see here, this lovely coronal section. And some computers can even produce 3-dimensional images. And then, of course, we have digital subtraction angiography. Digital subtraction angiography. Here, the goal is to look at blood vessels. And so an opaque medium, a dense liquid, is injected into the bloodstream. That ends up forming a lining on the inside of the blood vessels. And then using X-rays, they're able to see where these blood vessels are and perhaps determine, say, if a blood vessel is blocked. You might see a little darkness where there should have been blood vessel present. Then we have a variety of techniques that do not use X-rays. So they are potentially a little safer because there's no X-rays being used. This includes magnetic resonance imaging, MRI, magnetic resonance imaging. This technique uses magnetic fields and radio waves to allow for a three-dimensional view of the body. So again, very similar to CT scan, except now using magnetic fields and radio waves. MRI also is nice in that it can see through bones easier, and so you can get a better, more detailed view of structures hidden normally by bone tissue. So this is very safe, but also kind of expensive. Sonography is using high-frequency sound waves to look at the surface of structures. Most people know that sonography is used for looking at the developing fetus in a pregnant woman. Sound waves, very safe, much safer than X-rays. Sonography can also be used to look at the surface of, say, abdominal pelvic organs. So there are other clinical applications. And the sound waves go out, hit the structure's surface, and then bounce back, kind of like how radar works, or sonar. And finally, we have positron emission tomography. Positron emission tomography. The PET scan uses a very different technique. Basically, radioactive glucose is injected into the person's bloodstream, and then they use imaging to detect where that radioactive glucose goes. So here is a view of someone's head, seeing a slice of the brain, and they can say, oh, a lot of radioactive glucose is going to this area, so that might represent, say, a brain tumor that's developed because the tumor's taken a ton of glucose to grow and invade other tissues. Positron emission tomography, radioactive glucose, and detecting where that radioactive material goes in the body. All right, that is it for Chapter 1.